So first, thank you for the opportunity to share some of my research here with you. And so this is my PhD research I did. And I will talk a little bit about how immersion, that's this digital immersion when we are using these virtual reality headsets, how it impacts learning. So that's something I'm really interested in understanding more. As we can see with COVID, schools, they are going online. We are having to find ways to engage students and so on. And VR has been such an option that schools have been thinking of. So I want to understand how effective it is and how we can make it more effective when we use it. So I would just share my screen. Some of you have already know a little bit about my work, and some of you, maybe it's the first time, so feel free to make questions as they arise. Okay. So let's just go back. Okay. So first, there is this concept of different levels of technology that use immersion. It's not only the headset that we say about VR. We have this spectrum that we call the Milgram spectrum, where we go from the real world here on the left, where we have those glasses, like for example, Apple glasses, they are saying a lot about it right now. That's you can wear everywhere, and you have this digital layer over the real world. So you can still see everything, but you have over that one digital information. So that we call the augmented reality. There are some uses for education as well. That's not the focus of this study today, but it's increasing the use in education as well. We have the mixed reality headsets where you can actually manipulate the digital content over the real environment. So that's the difference between augmented and mixed. In mixed, you can really manipulate this digital content. And one example is the HoloLens from Microsoft. That's one of the devices most used. And they use especially on medical settings, on assembly lines, where you can see what you are doing, and then you have instructions to help you to go over the procedures you need to do. And the focus of this study today is the virtual reality headset, where you have this headset that blocks all the real environment. So you can't see the visuals that are around you. You just see this digital content in front of you. So it's very immersive because your brain understand part of this content as real, and we have several studies showing that we respond as it is real, and we have physiological responses to the environment. So this example here is one headset that you don't even need hand controllers to interact with the content. It has some cameras on that, so you can manipulate the digital content using your hands. What's more natural, but it's still beginning to be used. Okay. So we have these two important concepts when we talk about VR, that's immersion and presence. So immersion is this being immersed in the digital content, and presence is how you feel when you are immersed on that. So this picture, for example, is from the Virtual Human Interaction Lab here at Stanford, and there is this experience that we call the pit, where you have to cross this board from one side to the other, and there is this huge pit around you. And we have that about 1/3 of the adults that visit the lab, they do not cross this digital pit because they start to sweat, they feel anxious, and they just take the headset off and say, I don't want to go. So that's one of the way that we show how physiological responses are really enhanced when we are using VR. And when we talk about headsets, they really spiked, like the sales started to be more consumer based from 2014 and on, but we started to have headsets very early on. So here you can see like Sensorama was kind of the first virtual environment, a virtual reality environment. It's back on the 50s. On the center, you can see this picture is the first headset head-mounted display. It's from MIT on the late 50s. And here at Stanford, that's the kind of headset we have been using until 2014. It was really bulky. We needed a wall of computers and one computer science person, a professional, just to manipulate the computer. It was really difficult to run studies. So it was really centered on Stanford or in the labs all over the world. And when we start to have these more mobile headsets, we start to have more flexibility to collect data in schools, in museums, or anywhere. So we have now headsets that don't even need a computer. So for example, the white one on the top left, where you can bring it anywhere you want to use. And we have more accessible options like the ones on the top right. That's the Google Cardboard, where you can use your phone, insert it to it, and create a virtual environment more accessible. And that's one question we always have is, why do we use VR?
May I ask a question?
Yeah, sure.
Yeah. So I'm just curious because many of these pictures and many of the headsets clearly don't cover the subject's ears. And I'm curious as to whether this is really immersive reality if you are hearing one reality and seeing a different one.
So usually we have the sound paired with the environment. Do you mean the augmented reality headsets?
The ones that you're showing us now, and you know, the people, their ears are uncovered.
Oh,
even the ones in your lab, the ears are uncovered, so you can talk to the person in real reality.
So that's good.
They're participating in virtual reality with their eyes.
That's a good question, David. And it's just, I'm sorry, I didn't put it here. So here in the lab, they are not using headphones because we have specialized sound. So we have sound 360 degrees of sound. So it's really immersive sound, and we can put it really loud if we want. And here, the researcher is giving instructions, so the sound is off. But for those headsets here, they should be wearing headphones when using the headset. You cannot use it. So for example, the Oculus, that's the one on the top left, you don't need to use if you don't want. It has like a small sound coming from the sides of the head, but I wouldn't recommend because it makes it less immersive, and yeah, it's sometimes disturbing. So when we are working in schools, we always use the headphones to make sure that they are having more focused experience. And here, the cardboard on the top right, you can use either with the headphones on your phone or not. So it depends on how you want, how much immersion you want. Okay.
Okay, thank you.
And then, yeah, so that's always this question, like, why should I spend more money and buy some VR equipment if I can use a computer? What's the difference, right? And what we always say, we want to save VR for 4 special cases. So it's not for everything. It's not for being used every day. We save it for situations that in real life would be dangerous. So for example, here we live in California, we have earthquakes, and we know how important it is to have this training on how to behave in a case of an earthquake. So that's one of the experiences we have and we use in the lab. We developed because the San Mateo Fire Department asked us to have some VR experience to train people how to behave in case of an earthquake. And in the lab, to even increase immersion, our floor shakes. So you can really feel that you are having an earthquake because it shakes a little bit. And the importance here is that when we are talking about muscular memory, VR is very interesting because you can really move around. The system will track your movements. We have cameras all over the room. So if you move, if you run, the digital content will be refreshed according to your movements. And then you can train more precisely your movements in there. And training in real life would be very dangerous in this case, for example, of an earthquake. Other cases more towards education when we talk about corporate education, for example, oil and gas companies, maintenances of energy, power plants and so on. They can always train first in VR and then after go to the real environment. So this is one example for example, oil and gas training program that they can use in VR, using the hand controllers to train the movement that they need to do. And the studies, and I will talk a bit of that in some minutes, they show that for this kind of training, VR is really, really effective, because when we are talking about procedural knowledge, when we are talking about muscular memories, you can really repeat the movement with a lower cost and not being exposed to dangers. So it's more effective than just watching a video and trying to memorize what to do. So also for situations that would be impossible, when we want, especially in the research side, if we want to understand how people behave in certain situations that wouldn't not be able to put those people there, for example, flying, if they were a superhero, how they would behave after, if they engage in a altruist behavior in VR, would that be transferred to real life? So that was one question. We had several studies going on that. And we found that yes, people that were embodying a superhero in VR, after when they were in a situation where they need to help people, comparing to people that just had the same situation in VR, but not embodying a superhero, just watching what was going on, they were more altruist, they were helping more, who were in VR were helping more when they were out of VR, for example. And situations that would be counterproductive. So if I want to learn how cutting down trees would impact my pro-environmental behavior, and I want to enhance pro-environmental behavior, it doesn't make sense to put people to cut down trees. So I can do that in VR and see how it impacts. And again, we had that in VR. I can share all the papers of these studies with you later. And we found that participants that were in VR compared to participants that just cut down a tree on a computer monitor, the ones in VR, they used 20% less paper after the experiment than participants that just cut down this tree using a joystick on the computer. And also, and that's for me a very good reason for use VR in education, situations that would be very expensive in real life. So for example, if I want students to learn about the deep sea, about coral reefs, for example, having students from Brazil that live, for example, in Goiânia, Goiás, in the center of Brazil, taking them to the coast, and they would need to learn how to dive, to borrow equipment. We have the cost of the travel, we have all these things. It would be amazing if we could take all these students and take them there to learn, but given it's very difficult, just a very, very small percentage of them would be able to do so. I can bring more immersive experiences, more real for them, using VR for that. And that's what we most have in the lab, and the study that I used was this on the right image is one of these print screens from the experience we used. It's about climate change and how human activities impact the coral reef's life. And then, as a PhD student, I reviewed a lot of papers, a lot of systematics literature reviews, and it was really interesting to find that when we are talking about learning in VR, the results are not conclusive. It's not that, oh yes, VR is super good for learning. No, we have some studies showing that it's effective, and we have some studies saying that VR or computer are the same. You can use either, or some studies saying that VR actually is worse than computers. And I was like, so we need to find out what is going on, because if we are thinking about using VR at scales, at schools, a lot of students going through that, how we can make it effective, if it is. And this variation on the results, after really looking into these studies, we could find that, especially they vary according to the type of learning, the knowledge that they are focusing. So for example, when we are learning, we have the affective domain and we have the more cognitive domain. So affective is about emotions, engagement, motivation. practically all studies that I reviewed, they impacted positively, VR impacted positively the affective side of learning. So students were more motivated, more engaged, they were more curious about what they were learning, they would engage more time after taking the headset off, they would stay more time trying to learn more about what they just had in VR. And on the cognitive side, we have especially two types of knowledges. The procedural, that's one that we have steps, and especially it can be paired with a muscular movement, a physical movement, or just the steps as, for example, in math, you have equations and you have steps that you have to follow to solve the equation. For those kind of tasks, VR showed to be more effective than computers, for example, and even from face-to-face in some sort, so face-to-face interactions. For conceptual knowledge, then here is the key. Here's the where we have the most of the variation, and what we can see is that it really depends on the design of the experience. Then we go for questions as, for example, is the environment being too distractive? How it's built, so we can release cognitive processes to understand the information I'm receiving and connect that with previous information that I have. So that's the focus of my research on how we can use VR for conceptual knowledge. And then here, when we talk about the different types of using VR, for example, for sports training, it's really successful. You can see on the media a lot of teams, football teams saying that they are using VR. It's procedural knowledge and it's very successful. The same for example, Walmart, they use for training their employees on how to take care of the aisles and the products inside the store, very successful. On the healthcare, also for medical procedures, it has been showing the studies that's very positive using VR. But then when we are talking about schools and conceptual knowledge, then that's the question. And so when we talk about that, there's two other things that's important to think about. One, we have the immersive VR videos. What is that? It's when I use a 360 camera. That's a camera that has the ability to record images in a 360-degree angle. And I use that as my experience in VR. So I feel like I'm in a movie. That's a 360 movie where I can move around my head and see everything that's going on inside this sphere. I can't interact with that so far. We are changing that right now. We are being able to add layers of interaction, but so far the studies that used, it's only this passive, more passive experience. And if I move around, it won't change my position in this virtual environment. So it's like the sphere just moves with me. When I use computer graphics, then I have this, you know, like Minecraft, this pit you can see on the image here on the back. It was created by the computer. The realism is not the same as a 360 video, but I can interact much more. So when I'm talking about procedural learning, that's more important to have a computer graphics environment where I can move objects around as I would do it in the real world. So this is important to consider when we are thinking about VR in schools. So if I want to teach about conceptual knowledge, do I want a lot of interaction or just a more passive experience where the head movement allows me to explore the environment? Is that enough? So for the studies, first, here is the motivation. So it's all about that we have been discussing here, these different uses of VR and the impact on conceptual learning. And there is, on the affective side, there is one important concept that's self-efficacy. So self-efficacy, as many of you already know, is how I feel that I am able to learn. So how students feel that they are able to master some concepts, some subject at school. And Bandura from Stanford, he has more than 40 years of research on that field. And he has shown that as much self-efficacy students feel, their results academically and professionally increase. So it's a very important feeling that guides our academical choices, our personal choices, our professional choices. And to improve self-efficacy, usually it's not something very easy. You have to work with the whole environment, with parents, with teachers, with friends, because we learn how we feel that we are able to learn when we see the results of what we are doing. If I go and have a test and I really score high on that, then I will feel like, wow, I'm good at that. But if I do not have any feedback, I won't learn about that. So having the feedback is very important for developing self-efficacy. And VR allows you to that, is one thing. You can act into the world and have some feedback on that. And also in VR, you can have more agency. It means that you can feel that you're doing more than just, watching a video in a computer. So that's a concept that I investigated in these studies. So I conducted 2 studies. I compared the VR headset using immersive videos. So it was 2 videos about the ocean, where students were like inside the sphere and they can just move around their head and see and explore these beautiful real images from coral reefs in Palau and in the Mediterranean. And I compared to exactly the same images, but using a monitor computer. So students, they just accessed this video. They couldn't move the images. They were just staring at the screen and watching the movie. And study 1, we had a pre and post study design. So I used exactly the same questions before the experience, 2 weeks before, and immediately after the experience. And on the study 2, I had before, right after each experience, and 6 weeks after. So I delayed because I wanted to investigate also long-term effect of VR.
Can I ask a question on this?
Yeah.
Just trying to understand a little bit in terms of, in some sense, what you're choosing here is the desktop to be the counterfactual.
Yeah.
And I guess the question I'd have is trying to think a little bit about whether that's the right counterfactual. And it's not a bad counterfactual, but the hard part is, right, if we were to scale this up and use this as a means of augmenting, instruction at home, is it the desktop, or is it a specific piece of software, or is it a teacher and the teacher's ability to communicate on something? And I guess the question I'd have is, it'd be interesting to think about different modalities here that could be potentially control groups here, so that we get some idea of the hierarchy of learning, media.
Yeah, I think there a lot of room to do this kind of research, and I think we need that. My choice was comparing to the monitor and having exactly the same video, because I wanted to just investigate the immersion. So how just having more immersed experience, how it would impact learning. But it's extremely important to have these other kind of comparisons. From what I've been seeing when we are comparing, for example, with face-to-face instructions, VR, it's difficult to compare first because it's very different experience. Here you are more active on what we are, on the visuals, and when you are having a face-to-face experience, for example, in a classroom, it's more on the verbal side that you are. If you compare to field trips, of course, field trips, you will learn more. We have some studies showing that. If I could take everybody to to dive in the ocean, they will learn more than just having this experience.
I think that should be a Lemon Center, field trip that we should do, of some type.
Yes. But here, so just to answer your question, the choice was just because I wanted to investigate how just the immersion, if that was enough to change something. So just that. And the variables, so I investigated were the multiple choice learning assessment, where they answered 6 questions and it was right or wrong, so 0, 1. The open-ended, that's a more qualitative learning assessment. We had 6 questions, 3 about each video. We coded 0 to 5. Here we created a rubric based on the critical thinking theory, where each score represented how they answered. So for example, 0 was blank or I don't know. 1 was very, very weak answered, maybe not right, but they are putting some effort to answer that. And 5 would be a perfect answer, like with context, answering the question, applying what they just learned to a different context, bringing examples, so really well-structured answer. And we had two people, two researchers coding each answer, and they had to have the same score. If they didn't achieve the same score for each question, they would discuss until they have one only score for that answer. And then for self-efficacy, we used a questionnaire about self-efficacy towards science learning, because the experience is about science as well in the science class, coded 0-5. It's a Likert scale. And presence, that's this concept, this feeling that I'm inside the virtual environment, how I feel that I'm really, really inside that digital content. So we use 3 questions coded 0-5, a Likert scale as well. And then the hypothesis is that both would have similar learning gains, both in VR or using a desktop computer, and that participants in VR would have a higher self-efficacy score after the experiment than participants using the desktop. So those were the 2 hypotheses. So for the study 1, we had 53 female 8th grader students. We worked with a private school here in Palo Alto, and they were for 8th grade. The material was 2 VR videos, the Crystal Reef and Coral Compass. They are all available for free on YouTube if you want to try. And if you want to put your phone in front of you, you can have kind of the experience they had in 360. And the students using the computer, they used a MacBook Pro that was from the school. And students in VR, they use this headset that's the same on the picture, that's the Lenovo Mirage, where you don't need a computer. So it was much easier to go and bring, you know, for the whole classroom headsets and put all the students at the same time in VR. So here is the design of this first study. We had the pre-test 3 weeks before the treatment sessions, investigating the 3 variables. 3 weeks after, we had a 90-minute session where they had first one of the videos, and I split all groups in 2 for the video, so we don't have an effect of fatigue. So we have half of the VR, the students that were in VR, they had, for example, Coral Compass first and Crystal Reef after, and the other half the opposite. The same for the desktop condition. And after they answered questions about these 2 videos, they had the self-efficacy questionnaire. So for the analysis, we used just the t-test to compare presence, because we had only 1 measure at the post-test for them. And for the other measures that we had pre-test, post-test, we used the linear growth curve model. We fixed the effect of condition and of time to analyze how it affected learning towards over time. So here are the graphs using the scale of the codings we use it. So here you can see, and we will have some tests about the results. Maybe I would just skip some slides in front and we can talk here on the graphs. So you will see that the multiple choice questions, although we had random assignment, we had a significant difference at pre-test for the multiple choice. So students in VR, they scored higher at pre-test than students on the desktop condition. And then we ran the second study just to overcome this issue. And both of them learned a lot with the experience. We can see that from pre to post-test. There is no significant difference between groups. The same for the qualitative learning measure, the open-ended questions. We don't have a significant difference at pre-test, but they kind of follow the same learning gains from pre to post. So a significant difference between pre and post. And for self-efficacy, we had a small but significant difference at pre-test as well between groups. But running the mixed effect models regression, we found that even though we had a significant difference that was, how can I say, if we could put all of them, we found a significant difference at pre-test, we would still see a significant difference at post-test for self-efficacy, with participants in VR scoring higher than participants that were on the desktop condition. So here are the numbers I can share with you after, that just says that what we just presented on the graphs. And then, so we run the study to overcome these issues. We used a larger sample. Now I had 139 students. I used the matched random assignment where we do the following. We have the two high scorers. I put one in desktop, one in VR. And then the second ones, one desktop, one VR, and so on. So I'm sure that at the pre-test, we have the same, not significant difference between them. And I did that for learning. It worked for all the variables. We had shorter treatment sessions. So we broke the session in 2 of 45 minutes, one in one day, the other on the other day, and one video on each session. So we wanted to see if it makes a difference, if they were tired maybe on the first time, if it would change. And then we measured self-efficacy after each video. So at the study one, if you remember, it was just after all those videos. So I couldn't see if there was, impact of one video or other more on self-efficacy. And we added this delayed post-test. So 6 weeks after they had, again, the same questions, the same test to see how, if we had a difference after treatment, if it would keep after some weeks. And this time also we had more students from 6th grade to 8th grade, not only 8th graders. So the age here from 11 to 14 years old. The same school, all girls school. The students that were on 8th grade on the study one, they were already graduated from this school. So there was really completely different sample here. The same material, the same equipment we used. And then, so we had here between pre-test and treatment, we have more time. We had 5 weeks and 6 weeks for the delayed test. So the structure was pretty much the same. The only difference is that we had these 2 sessions, and with 1 or 2 days in between those sessions, the treatment sessions. Again, splitted the groups. Half of them had one video first, half of them had the other video first. And we had, after 6 weeks, measuring all exactly the same questions from the pretest. And here are the results that we found this time. So for the multiple choice, that's the quantitative measurement, we couldn't find any significant difference between conditions over time. So they kind of had the same learning gain. The difference between after treatment and delayed post-test when compared to the pre-test was significant. It means that they learned. In both conditions, they learned a lot, but between conditions, we couldn't find any difference. When we talk about the qualitative measurement, that's the open-ended questions, we found a significant difference here on time 1 and 2, where students in VR, they scored higher than students on the desktop condition. And the same happened for self-efficacy. We had students in VR scoring higher than students on desktop condition on time 1 and 2. On the delayed measurement, all of them, they kind of got together. So we didn't find any significant difference between conditions on the delayed post-test, what says that the long-term effects of VR were not sustained here. They equaled to the computer use after 6 weeks. And if you see here on the self-efficacy, there is a slow reduction here on the delayed post-test. And what our hypothesis of this, they had a level of self-efficacy, they increased after treatment, and then it decreased a little bit after. it was kind of a surprise for me, because it was like, well, learning, I understand, memory affects, so you won't remember that much 6 weeks after. But for self-efficacy, so what we found is that given you say how much you feel you are able to learn based on past experiences, and they were answering exactly the same questions at the delayed post test, probably when they were answering it, they remember that they did better 6 weeks before, like it was, you know, the content was fresh on their mind 6 weeks before, and and maybe that impacted how they felt, because it happened on both groups, desktop and VR as well. Okay, and then here are all the data, the numbers from the results. And so for the discussion of that, we replicated one, so I couldn't find only one study that compared VR and desktop on a more systematic way, very similar to what I did, and used not only learning, but also self-efficacy as variables. And it was exactly the same results. No significant difference on the learning side, but a significant difference on the self-efficacy measurement, with students in VR scoring higher just after treatment. In these studies from Akransky, he didn't measure long-term effects, and he used computer graphics. So ours used the video, VR video, not computer graphics. So it's a little bit different on here. And one explanation of increasing self-efficacy after the experience in VR is that we already know that VR increases engagement and increases motivation to learn, and these and enjoyment, and those are aspects that also influences self-efficacy. So that was one of the hypotheses of why self-efficacy increased, just having this difference of just having the immersion more. And so the conclusions from those two studies are that the results, they are slightly different, not that much, but for conceptual knowledge, it was interesting to have as a first study and see that maybe when we are using VR, and we need to think about what kind of knowledge we are focusing on and what would be the best experience. Is that a high level of interactivity most important, or just having them time, giving them time to explore and look around, and being able to connect what they are learning with what they already know, more important than that. And when we talk about affective side of VR, yes, it's one more evidence that VR impacts positively emotions and engagement and motivation to learn, conceptual or procedural knowledge. And for future studies, before adding VR to schools all over and having its use at scale, it's needed larger samples. We need more studies with that. This one was one of the first with more than 100 students. Most studies in VR, they have like something between 25 to 40 participants. We need a more diverse population. So this study was really focused on a wealth community here in Brazil, here in Palo Alto, a private school. We need more diverse population to see how it will impact. And also having these multiple points before, right after, long term. We use it 6 weeks here, but I would also go for more time, like 2 months, 3 months, 6 months. And also having different kinds of learning assessments, because we know like multiple choice questions, they are tricky to assess learning. Qualitative and open-ended questions, they go more in deep. You can evaluate better the student, but there is the subject aspect of who is scoring that on that as well. So pairing different kind of learning assessments is really important here as well. So yeah, that was it that I had to share with you today.